I'm now going to try and work through the problems on this Math 137 test number 3 review. So here's the review. You can see the first 3 problems are trig identities. I'm going to go ahead and do these on a separate piece of paper, but on all these, I will be working with the left-hand side and then try and get the left-hand side to equal the right-hand side. So let's go ahead and start with the first one. Sometimes working trig identities can be a little bit of a trial and error. I went ahead and worked these out beforehand just to make there weren't any issues with Don't want to waste time on the video trying to figure these out. So the first one is cotangent of x over cosecant x minus cosecant x over cotangent x equals negative sine of x times tangent of x. What I almost always do, first thing is whatever side I'm working on, convert all these to sine and cosine. Usually, at least for me, that allows me to make some progress. So cotangent is cosine of x over sine of x. Oh, hang on. An alarm to remind me to do something. Cosine of x over sine of x. Cosecant is 1 over sine of x. Minus cosecant is 1 over sine of x divided by cosine of x over sine of x for cotangent. First thing I notice, we have some complex fractions here. This sine of x and this sine of x cancel out, and this sine of x and this sine of x cancel out. So now I end up having cosine of x minus 1 over cosine of x. What I'm going to do now is I'm going to combine these into one fraction. So I got to have a common denominator of cosine of x. So that means I have to multiply the top and the bottom of this cosine. So then it becomes cosine squared over cosine of x. Now, one of the most common used identities, I'm going to use it right here for this numerator. The one that you use more than any other is sine squared plus cosine squared equals 1. What I'm going to do is I'm going to rearrange this and have cosine squared minus 1. So I'm going to subtract 1 from both sides. Now I want to get to cosine squared minus 1 by itself, so I'll subtract sine squared from both sides. Sort of a roundabout way to do this, but basically what I wanted to show you is cosine squared minus 1 equals negative sine squared. So I'm going to replace this with negative sine squared of theta over cosine theta. So now, oh, I jumped from x's to thetas. Doesn't really matter. I'm going to sine squared theta, write it out as sine times sine over cosine, just to make it very obvious. And obviously sine over cosine is tangent. And if I want to put it in the order up here, I'll move the sine out front. All right, so hopefully that's clear. Number 2, sine theta over cosecant theta minus cotangent theta. And we're going to show that that equals 1 plus cosine theta. I'm going to work with the left-hand side once again. Let's convert everything to sine and cosine. Cosecant is 1 over the sine of theta. Cotangent is cosine theta over sine of theta. And you can see here in the denominator that I already have the same denominator, so I can combine these into one fraction. And one of the rules of complex fractions is when you have this sign, it's going to actually go into the top. So I end up with sine squared theta over 1 minus cosine theta. And now the sine squared theta, I'm going to go back and use this identity again. It's pretty easy to see sine squared of theta is 1 minus cosine squared theta. So let's jump over here. So all right, now I'm at sine squared theta over 1 minus cosine theta. I'm going to replace sine squared theta with 1 minus cosine squared theta, 1 minus cosine theta. Now here's something you just have to sort of see when you do these enough. 1 minus cosine squared theta is actually a difference of squares, meaning we can factor it. And it would be 1 plus cosine theta times 1 minus cosine theta. That's all over 1 minus cosine theta. You can see that those cancel out. I'm left with 1 plus cosine theta, which is what we wanted to prove. All right, one more, if I can squeeze it in here. Cosine theta over tan theta plus secant theta. We need to show that equals 1 minus sine theta. So I'll take the left-hand side. Let's convert everything to sines and cosines. Tangent is sine theta over cosine theta. Secant is 1 over. So I can actually add these two fractions in the bottom since I have a common denominator. And now I can simplify this complex fraction. What's going to happen is this cosine is going to go to the top. Now this is beginning to look like the problem I just finished, because what I'm going to do is I'm going to substitute in for cosine squared theta. I'm going to go back to this identity. Cosine squared theta is 1 minus sine squared theta. So if I go down here, instead of cosine squared theta, 1 minus sine squared theta over sine theta plus 1. The numerator I can think of as the difference of squares. So it's 1 plus sine theta times 1 minus sine theta all over sine theta plus 1. Now you realize when you're adding, the order doesn't matter. 1 plus sine theta is the same as sine theta plus 1. So those cancel. And I'm left with 1 minus sine theta, which is what I was trying to prove. All right. So that was 3 trig identities. Now let's go ahead and start working on the rest of these problems. Maybe some of them I can go ahead and solve the following equations, give the answer in both general form, in other words, for all angles, and then what I call the specific solution from 0 to 2 pi. So remember, these kinds of problems, I think of them as a two-step problem. First thing is you solve for the trig function. In other words, get the trig function by itself. And then once you do that, you actually solve for the angle. So for this one, if I want to get sine theta by itself, I'm going to subtract 3 from both sides. If I want to get sine by itself, divide both sides by 2. So now I've solved for the trig function. Now I think to myself, I need to solve for the angle, because ultimately, all of these problems, the answer is going to be an angle. So I ask myself, what are the angles where the sine is negative 1/2? What I'm going to do is I'm going to think of going around the unit circle once. So you can look at your unit circle, although hopefully some of you like me sort of have it memorized. So where is the sine of theta negative 1/2? Well, the sine is negative in quadrant 3 and 4. So in quadrant 3, I know that the angle 7 pi over 6, the sine is negative 1/2. Now to make this the general solution, I have to add the 2 pi n. I'm not going to write the n equals 0, 1, 2, 3. But there's actually a second solution on the unit circle, and that's also (11 pi over 6). So these are the general solutions. Now the specific, I start plugging in numbers for n, and I look for the angles that are between 0 and 2 pi. So when n is 0, for the first one I get 7 pi over 6. And then I get 11 pi over 6. If I plug in n equals 1, I get 2 pi plus 7 pi over 6. Well, obviously, that's going to be outside of my allowed angle, and the same thing here. So the general solution, specific solution. All right. So that was 4. Let's do 5. Same idea. When I get the cosine by itself, let's go and subtract 1 from both sides. Let's multiply both sides by -1. End up with cosine theta equals 1/2. So same thing we just did. Ask myself, one trip around the unit circle, what are the angles where cosine theta is 1/2? It's going to be in quadrants 1 and 4. That's where the cosine's positive. And the first one is pi over 3. So there's the general solution. Then if you go to quadrant 4, you have 5 pi over 3. And of course, you add 2 pi into both. Now, for the solutions between 0 and 2 pi, when n is 0, I have a solution of pi over 3 and a solution of 5 pi over 3. If n is 1, 2 pi plus pi over 3 is outside my allowed interval, and the same thing happens with 5 pi over 3. So basically, that's going to be my specific solution. Another one looks like the same thing we've been doing. I'm going to skip a few steps. So if I subtract 1 and then divide by 2, should have sine of theta equals -1/2. You know what? That's actually the same. The same problem as problem 4. So actually, same answers as problem 4. It's not too good to have a question that ends up being the same question. But number 7, subtract 1 from both sides. So the general solution for what angle is the cosine -1 happens at pi. That's the only time around the unit circle that the cosine equals -1. Of course, I have to make it, add the 2 pi in. So therefore, you start putting in numbers for n when n is 0. You get pi. If n is 1, you get 3 pi. But once again, that's out of my allowable interval. So the general solution is just theta equals pi. All right, a few more of these. This one, subtract 1 from both sides. Tangent's a little trickier because basically in my mind, what I say to myself is tangent is sine over cosine. So I got to find an angle where the sine and the cosine, they're going to be equal because it equals -1, but they have to be opposite signs. So I know sine and cosine are the same at the pi over 4 angles. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. But since I want it to be -1, I need to find quadrants where the sine and cosine are opposite signs. And that occurs in quadrants 2 and quadrants 4. So now I'm looking for my pi over 4 angles in quadrants 2 and 4. So for the general solution, quadrant 2, it's 3 pi over 4. Now here's something that's a little tricky. The way it works, when you're given a solution for pi, you don't add 2 pi like all the rest, but with tangent, we just add pi over n. Now, when I do that for my general solution, I don't need to have a second general solution of 7 pi over 4, because when n is 1, this thing is going to equal 7 pi over 4. So it would be redundant. So there's just one general solution. Now for the specific solution, when I plug in 0, you get 3 pi over 4. When you plug in 1 for n, you get pi plus 3 pi over 4, which ends up being 7 pi over 4. And those are going to be your specific solutions. Here we go, cotangent. Let's do this. Let's solve for cotangent first. And then once I solve for cotangent, then I'm going to switch it to tangent. Because remember, I like to do all my problems in sine, cosine, and tangent. I don't want to mess with the cotangent. Let's go and solve for cotangent. So I'll subtract 1 from both sides and then divide both sides by square root of 3. So you end up with -1 over square root of 3. At this point, I'm going to go and change cotangent to tangent. So all you have to do is flip the fraction. Now, once again, here's a tangent problem. So I'm thinking to myself, let's go find an angle where the sine and the cosine would equal negative square root of 3. If you think about it, that's going to be one of those angles where the sine is square root of 3 over 2 and the cosine is 1/2. Because when you divide those, you get square root of 3. So that normally happens at the sort of like the pi over 3 angles. Now, because I want to be negative, I guess I have to go to the third quadrant. And the third quadrant is going to be 4 pi over 3. But once again, since it's tangent, we're going to add pi in. And normally I would also put well, I still may need to put 5 pi over 3. Let me think about it. Oh, sorry. Quadrant 3, the tangent is actually a positive number. Maybe some of you thought that when I wrote this answer. Actually, the tangent's negative in quadrant 2. So it's 2 pi over 3 plus pi n. So now, if I put in a 0, you get 2 pi over 3. If I put in 1, you get 5 pi over 3. And then after that, you're outside the interval. All right, last one. Because you see, from 10 to 11, the big difference is so far, all these problems have just had theta inside the trig function. 11 has 2 theta, so everything's going to change, or it's going to require a different way to solve it. But this last one still has just theta. So let's solve for the secant. Might skip a few steps. So I'm going to subtract 6 from both sides. Then divide by 4, so it's going to be -8/4. So we have the secant of theta equals -2. Of course, now I'm going to switch secant to cosine. So you can think of this as 2/1. So if you flip it, we have cosine of theta equals -1/2. And you know what? Earlier I had cosine of theta equals 1/2. Now we have -1/2. So there's two solutions around the unit circle. Cosine is negative in quadrants 2 and 3. So I'm going to have 2 pi over 3 plus 2 pi n, and then 4 pi over 3 plus 2 pi n. Now for my specific solutions, when n is 0, 2 pi over 3. When n is 0, you get 4 pi over 3. If n is 1 for both these, and you're outside your allowed interval. So therefore, here are two solutions. All right, let's take a break. And when we start the next video, we'll start tackling these problems where instead of having just theta inside the trig function, we've got things like 2 theta.